Okay, hi, I'm Ian. This is not my day job. This is something I do for fun. I have the world's smartest house. If you don't believe me, you can Google that and you'll find the world's smartest house, which proves how good I am at SEO. And the house has hundreds of sensors in it, has sensors throughout. You can chat to it. It has a natural language interface that I wrote from scratch. It has a web interface. It had a mobile app at one time. It tracks the temperature, the weather, the sunlight. It tracks everything, and it stores all that data. I have all that data going back several years. My goal really is, how smart can I make a house? What scenarios are interesting? And ultimately, can I have a house which just learns and predicts what you're going to do and does it for you? So the house becomes the user interface. There is no need for an Alexa. You don't talk to my house. You walk around, the lights turn on automatically, they turn off behind you. You never need to touch a light switch in my house. On a typical day, I do not touch a light switch. One of the best sensors is these strain gauges under the floor that measure the deflection in the beam as you walk around and ignore the dog. But it still didn't learn, and last year I gave this little talk and I lamented the fact that I hadn't done any learning yet, and 2 weeks ago I realized I still hadn't really done that, so I better get on with it if I'm going to talk this year. Why doesn't it learn? Because, this data, it's messy data. It's not labeled. I've just got a stream of sensor data. I'm not going to sit there and label it all and go, oh, somebody moved from the kitchen to the bathroom, and then, it just take forever. I don't have enough examples of some events. It's got 3 Christmases in there. It's not going to learn from 3 Christmases. It's sparse temporal data. It's intermingled data. There's 2 people walking around together. All their streams are mixed together. And the only feedback you get is really kind of negative. If somebody does touch a light switch, that's kind of a training event. I failed if they have to touch the light switch. And it's an evolving world. So I'm also involved in NLP. I have a natural language engine, as mentioned, and it struck me that this looks a lot like a sentence. Sensor 1, period. Sensor 2, period. But it's a bad sentence. It's got duplicate words in it. It's intermingled like I described, and there's these long, meaningful pauses between some words. So one technique we can use in NLP is called n-grams, where we analyze this, then that, combinations of words, 2s, 3s, or more, and find all the counts of the bigrams. So I set about doing that. So it took about a couple of days to compute that on my 500 gigabytes of sensor data, built up 10 million n-grams. You can look at those n-grams over time as well. I have a temporal aspect that I'm not using today, but you can see how long it takes to get from the back door to the kitchen floor. On average, and all the distribution of that. And then I'm trying to use these n-grams to decide who moved. So you look at the ratio of the tracks. So I've got a hypothesis. There's one person in the kitchen and one person in the dining room right now. I can look at the ratio of kitchen to dining room versus dining room to dining room, and I can make a decision about whether did that person move from the kitchen to the dining room, or was it the same person in the dining room staying where they were, and come up with a probability. And so I could use the ratio of the different n-grams and compute the next scenario. So in the next scenario, 96% probability that nothing happened. The person in the dining room triggered the same sensor, they stayed there, 0.04 that somebody moved from there to there. But the problem with n-grams is they get distorted by frequent events. So you've got this kitchen floor, which is a really noisy sensor. It's really chatty. People trip that a lot. And so it came in with 52 count versus only 26 for the dining room to dining room floor. But there's a technique called TF-IDF, term frequency inverse document frequency, where we look at how common one of these words is, and we divide it, roughly divide, I'm simplifying here, and then we come up with this TF-IDF score, which works much better. It says that it's 20 times more likely that when you walk on the dining room floor that if you were already in the dining room, that was you, than it was the person coming from the kitchen. So I can do that TF-IDF, I can look at all the data, and remarkably, the house has figured out a graph model of itself just from dumb sensor data. It knows which rooms are connected to which rooms, which sensors are near which other sensors, just based on this TF-IDF. But it still makes mistakes. In the morning, there's lots of activity in the bathroom and lots of activity in the kitchen, and it thinks that you can hyperspace bypass from the bathroom to the dining room or kitchen and backward and forward. So we have to get rid of some of that, fake correlation data. But luckily, I have a graph model of the home. All the sensors are represented in a graph model. Sensor is in a room. I need more than 20 seconds, come on. It's 10 years of research here, man. So I use the graph model to weed out the hypotheses that can't possibly be right. So every time I get a new sensor input or a lack of motion, I compute the new hypotheses, discard the unlikely one, sum that across all the tracks, and I get P of n for n people in a room. And it works really well. So it can give me a probability of how many people are in any room. Wait, you'd have to hit me to get me off it. I've got 2 more slides, which no dumb sensor can do. But so you can use dumb sensors to come up with smart data. It also will try to label the tracks with Wi-Fi, because it tracks everybody coming in the house with my Google Starbucks honeypot. So the result, I can now create a home automation system where it actually turns the lights off when you don't move, and it's reliable. It never puts the lights off on you just because you sat there too long. I can do things like put the heating on if there's 2 people home, instead of, if I'm there alone, I'll be on the treadmill. I don't need the heating on. But if there's 2 of us there, I can put the heating on, and it can do unusual behavior. So now I've got labeled data. Next year, if there's one, I'll be here, and I'll tell you which of all these different techniques I've decided to use against that labeled data to come up with the ultimate home automation, which is a predictive house for any house, so that you could put this in your house, it would learn what goes on, and it would start doing what we do, where the lights turn on ahead of you. If it's not sure, it'll turn both lights on, and then turn off the one that you didn't go into, and it'll turn off all the lights behind you. You'll save energy, and I'm being thrown off. Come and find me afterwards. I can tell you more. Bye.
Awesome.